All right, hello and welcome back to the virtual classroom. We are moving forward this week talking about a topic that we're kind of a little bit of review and a little bit of extension here. So looking at some one-step equations, but now this time when those equations involve fractions. So starting off a little bit of review just about how we solve an equation to kind of slowly jump back into things. So stating the inverse operation of each, because remember when we solve equations we're going to be using those inverse operations to undo the operations that are in the equation and then be able to get the variable isolated or by itself so we can find out what its value is. So starting off stating the inverse operation here, so adding 23, the inverse operation would be to subtract 23. Or you could actually achieve the same thing with adding a negative 23, right? So either way there would achieve that. Subtract 18, the inverse operation would be to add 18, or we could subtract negative 18. Adding a negative 9, we could subtract negative 9, or we could add positive 9. Multiply by negative 3, the inverse operation of that would be to divide by negative 3. And dividing by 25 as an operation, the inverse operation, multiply by 25. Okay, so now applying that principle to going back and remembering how to solve a one-step equation here. So here's 6 equations for us to solve. The first one we've got v over 2 is equal to 17. So remember we're going to draw our line to separate the two sides of the equation. We're going to find our variable and determine what inverse operation needs to be performed in order to get the variable by itself. So here we have v over 2. Remember that's the same thing as having v divided by 2. So inverse operation in division is multiplication. So we're going to multiply both sides of our equation here by 2. Going to cancel out the 2's on this side then, leave us with v like we're wanting. Over here, 17 times 2 makes 34. So we get v is equal to 34 here. For number 2, again, draw my line. Here's x. I want to get x by itself. Right now it has a negative 9 being added to it. So as we showed up here, if it's adding negative 9, then we can either subtract the negative 9, or, remember that's the same thing as just adding 9. So we can undo a negative number that's being added by adding its positive, because it's the same thing as subtracting its negative, right? The two negatives there would make a positive. So if I add 9 here to both sides, cancels out the 9 here, leaves just x, and 5 plus 9 makes 14. Number 3, negative 20 equals 10n. Draw my line. This time the 10 is attached to the n. There's no operation symbol in between. So remember this shows multiplication. In order to undo that, we have to use division. So if we're going to divide by 10 both sides, we get negative 2 is equal to n. Number 4, 9 equals n plus 3. Find our variable. It has a 3 being added to it, and it's positive. So in order to undo that, we're going to subtract negative 3, or that'd be the same thing as adding a negative 3. I'm sorry, so not subtract negative 3, subtract just 3, or add negative 3. And over here, 9 minus 3 makes 6, and so we get that n is equal to 6 here. Number 5, here's our variable r. It has a negative 10 being added to it, so again, to undo that negative 10, we're going to add 10 to both sides. Remember combining integers over here, if I combine a negative with a positive, I'm actually going to subtract the numbers and keep the sign of the larger. So subtracting these gives me 16 as a difference, and the larger was the negative, so it'll stay as a negative 16 then. And then for number 6, n over 3, and so that's division. I need multiplication then, so multiply both sides by a positive 3 to cancel that out, and that'll give us negative 48 as our value for n. Okay, so just to recap, again there about how we solve one-step equations. But now adding fractions to the mix. So when equations have fractions that are added or subtracted to the variable, use the proper inverse operation still to solve the variable just like it was a whole number or integer. But remember that you'll have to make common denominators in order to add or subtract the fractions together. Okay, so same concept, same idea, same technique, but we just have to remember that when we go to combine our fractions, or fractions and whole numbers, whatever the case might be, how to actually add and subtract those fractions together. Okay, so we're going to use a couple concepts from earlier in the year to make this possible. So for this example down here, we've got x plus 3/4. So again, it's just addition of 3/4. So in order to undo that, I'm going to be subtracting 3/4. But what that gives us here is I have 3/16 minus 3/4. So if I think about doing that, remember we have to have common denominators. So I have a 16 and a 4 currently. In this case, I can turn the 4 into a 16. So remember, when we make common denominators, we always make a bigger number, right? So we always want to go up to the bigger number. If you could make the smaller denominator into the larger denominator, that's the easiest way to make common denominators, which we can for this one. If we can't, then we just have to go to that first common multiple, or first common denominator. But again, we don't ever want to make them the large number small. We want to make the small numbers big to match in this case. So to do that here, the first fraction is still going to stay as 3/16. In order to turn the other fraction into a number of 16ths, remember we have to multiply that means the bottom by 4. But in order to keep it an equivalent fraction, multiply the top by 4 as well, which is going to make that 12. And so now what we end up with is 3 minus 12 on the top. That's going to make -9. And then remember that we don't change the denominator. So the denominator stays the same. We're taking 3/16, subtracting away 12/16. It still gives us a number of 16ths when we do that. So here we're going to get that x is equal to -9/16. Now remember, we always want to try to reduce our fractions if possible. In this case, 9 has factors of 1, 9, and 3, and none of those are going to be common factors of 16. So in this case, -9/16 ends up being our answer. But remember to try to reduce those fractions if we can. Okay, for number 2, the inverse operation of adding -2/3 would be adding +2/3. So if I add +2/3 there, it's going to get that to cancel out. Have to do the same thing on the other side. Okay, now here's a situation where I'm starting with a whole number and adding a fraction to it. Now I could make it 5/1 and add 2/3, in which case I need to make common denominators. Or I can just think about what's happening here. I'm taking 5 and I'm adding 2/3 to it. And if I do that, remember I can keep it as a mixed number then, which would mean it's just 5 and 2/3. So here we get x is equal to 5 and 2/3 for our answer. So don't always necessarily have to overthink things and make it more complicated than it needs to be. If you have 5 and you add 2/3 of it to it, you just get 5 and 2/3. Okay. The rooster next door is saying good morning to everybody here. So if you hear that in the background, my neighbors have chickens and a rooster. There he is again. Using the reciprocal or multiplicative inverse. So fractions can be canceled out by multiplying by their reciprocal or multiplicative inverse. When equations have fractions and you want to cancel those fractions out, so when they're coefficients, meaning they're in front of the variables, or we just want to cancel out a fraction that's in there, one thing we can do is we can multiply by the reciprocal or multiplicative inverse. Now what a reciprocal is the flipped form of the fraction. So if I take a fraction and I flip it over, that's what we call its reciprocal. So the numerator becomes denominator, denominator becomes numerator. So it says to identify the reciprocal of the following fractions. Well, 3/5, the reciprocal of that would be 5/3. And notice that if I were to multiply those two things together, the 5's cancel, the 3's cancel, and I end up with just the whole thing canceling out and just making a 1. And that's why multiplying by its reciprocal will cause it to essentially cancel out in the problem because it'll make it a 1. Negative 13/50ths, the reciprocal of that, still negative, so all we're doing is just flipping, we're not changing the sign. That would be called its opposite reciprocal, which could be used for something else in math. But in this case, it'll still be negative, and 50/13 then for its reciprocal. And here we have 41/30, reciprocal of that, 30/41. Okay, so now where we're going to use this is when our, as we were stating a minute ago, when we're solving equations with fractional coefficients. So the coefficients, the number in front of the variable, is a fraction. So to undo a fraction that is a coefficient, or attached to the variable by multiplication, such as 1/2 x, right? In this case, the 1/2 and the x are attached together. That makes the 1/2 its coefficient, and it's a fraction. We're going to multiply both sides of the equation by the reciprocal of the fraction. Now, you might be saying, why aren't we dividing, right? If it's showing multiplication here, why are we not dividing? Technically, we are, okay, and I'll show why real quick. If I had 1/2 x, let's say, is equal to 8, and I wanted to get x by itself. Now, what I could do is I could divide both sides by 1/2. And when I divide both sides by 1/2, that is going to cancel out over here. 1/2 divided by 1/2 does make 1. Over here, I have to do 8 divided by 1/2. But doing 8 divided by 1/2, what does that mean I actually have to do? Anytime I divide by a fraction, I have to do everybody's favorite restaurant. Just kidding. KCF, right? So it's not KFC, it's KCF. It's keep, change, flip. So I would actually be keeping the 8. I would be changing it to multiplication, and then flipping the second fraction to make it 2/1, which is the reciprocal of 1/2. So I could have, instead of dividing by 1/2 over here, just multiplied by the reciprocal on both sides, which is 2/1, and it achieves the same thing, right? So this moves up, becomes multiplication, and I get the same answer there. Okay, so instead of dividing first and then end up just changing it to multiplication, just remember to just multiply by the reciprocal from the start. But again, this is only used when our fraction is attached to our variable. So we only want to multiply by the reciprocal when that's the case. Okay, so we're going to solve each equation here. So for number 1, it's kind of a step-by-step. So we're going to solve 3/5 t equals 6. So the coefficient of t in this case is 3/5. The reciprocal of 3/5 would be 5/3, right? So 5/3 is the reciprocal of 3/5. So that means that I can multiply each side by the multiplicative inverse, or the reciprocal. In this case, 3/5 multiplied by 5/3 here, and 5/3 over here. Over here, what's going to happen is the 5's and the 3's cancel, and so it's going to cancel out both numerator and denominator there, just making it a 1, so I end up with just t. Really, it's 1t, but that's the same thing as just t. Over on the other side, I actually have to multiply 6 times 5/3. Remember to do that, I do top times top, bottom times bottom. So 6 times 5 is going to make 30, over 1 times 3 is going to make 3. That gives me 30/3, though, which I can divide both top and bottom by 3, or just view it as division now, 30 divided by 3. And that's going to give me 10. So I end up with just t equals 10 from that problem. Okay, a couple more examples here. So number 2, I've got negative 1/7 x is equal to 3. Again, going to get rid of that coefficient, that fractional coefficient, by multiplying both sides by the reciprocal. In this case, it's a negative, and in order to turn that into a positive x that I want for my answer, remember that means I also need to multiply by a negative on both sides here to achieve that. The reciprocal of 1/7 is 7/1, or that's just 7, right? So multiplying both sides by negative 7/1 here, or really that's just multiplying by negative 7 on both sides. That cancels out the 7's, the 1's, the negatives, and all I get left is just x, like I'm wanting there. On the other side, 3 times negative 7/1, again that's just 3 times negative 7, which makes negative 21 here. Okay, number 3, 4/3 equals 2/3 x. Here's my x variable. It has 2/3 as a coefficient. multiply by 3/2 is the reciprocal there to cancel it out. The 2's cancel, the 3's cancel, and I'm left with just x, like I'm wanting. Over here, I get 3 times 4 on the top. That makes 12 over 2 times 3, which is 6. And I'm left with 12 over 6, which 12 over 6 is going to just make 2 when I divide that or reduce that down. Okay? All right, moving right into the conclusions here. So, adding and subtracting fractions requires the fractions to have common denominators. Okay, and remember that's only when adding and subtracting. As we saw, when we multiply and divide with our fractions, remember we don't have to make common denominators there. We simply just multiply straight across. So top times top, bottom times bottom. Describe what the reciprocal of a fraction is. So it's the flipped form of the fraction. So for example, 2/3, the reciprocal of that is 3 over 2. When do you use the reciprocal to undo a fraction? When the fraction is the coefficient of the variable. Because in that case, we want to divide both sides of the equation by the coefficient, but as we showed, dividing by the fraction, we have to use KCF, keep, change, flip, and that ends up just being multiplying by the reciprocal. So number 4, write an equation or an example of an equation that contains a fraction but does not require the using the reciprocal to solve the equation. So when we don't need to use the reciprocal, that's when the fractions are just being added or subtracted. So I could have something like x plus 5/4 is equal to 18. And in this case, I would just be subtracting 5/4 from both sides. And to get it by itself, I don't need to do the reciprocal or use the reciprocal in that case. Number 5, write an equation with that contains a fraction and requires the use of reciprocal to solve the equation. And so again, in this case, we want there to be a coefficient that is a fraction. So if I have something like 2/3 x is equal to 15. Okay, in this case, in order to get rid of the 2/3, I'm going to use the reciprocal of it, flip it over, and multiply both sides by 3 over 2. So in summary, use words to describe how you would solve the equation. So in this equation, we've got 1/2 plus x is equal to 3/8. And so in order to solve that equation, we would add 1/2 to both sides. Now actually solving the equation. So if I do that, add 1/2 to both sides here. Again, these ones are going to cancel out. X is going to be equal to 3/8 plus 1/2. When I add and subtract fractions, I have to make common denominators. In this case, the smaller denominator 2 can be turned into the larger denominator 8. So in order to do that, keep the 8's the same, or the 3/8 the same. But here, multiply top and bottom by 4, and turn this into 4 over 8. Remember, we only add the numerator, so 3 plus 4 makes 7. Keep the denominator the same, and so we end up getting 7/8, which is already simplified or reduced. Okay, and use words to describe how you would solve this equation. So negative 1/2 x is equal to 3/8. In this case, we need to multiply both sides by, and in this case, since it's negative 1/2 that's attached to the x, showing multiplication, to undo that, we divide by negative 1/2, but really that's the same thing as multiplying both sides by its reciprocal, which is still negative, but it's going to be 2 over 1, or that's the same thing as just negative 2. Okay, so showing that here, multiply both sides by negative 2 over 1, or just negative 2. And over here, that cancels everything out. We get x by itself. And then multiplying here, 3 times negative 2 makes negative 6 over 8 times 1 is 8. That can be reduced, though, because I can divide both of those numbers by 2. So I'll do that, and I get negative 3 over 4. Okay, so again, just kind of combining a couple techniques, yes, from earlier in the year. So solving equations, but now involving with fractions. So remember, when you add and subtract fractions, you got to make those common denominators. Multiplying fractions or fractions that are being multiplied to their variables that are coefficients, we really are dividing to get rid of them, but that is simplified to just multiplying by the reciprocal or the multiplicative inverse. Okay, there's a worksheet on this, so go complete that, and we'll be talking about two-step equations to follow up with this, and a technique that's called fraction busting if we want to just get rid of the fractions from our equations. All right, good luck.